Next, we're going to look at an application of functions. If your car is going 35 miles per hour on dry pavement, your required stopping distance is 160 feet, or the width of a football field. At 65 miles per hour, the distance required is 410 feet, or approximately the length of 1 1/10 football fields. Figure 7.6 shows stopping distances for cars at various speeds on dry roads and on wet roads. So the dry pavement is in green, and then the corresponding blue bar graph is the wet pavement data. Figure 7.7 uses a line graph to represent stopping distances at various speeds on dry roads. For part A, we want to use the line graph in figure 7.7 to estimate a car's required stopping distance at 60 miles per hour on dry pavement and round to the nearest 10 feet. So to read this properly, we want to go to the correct 60 miles per hour, which is on the x-axis, and then we want to go up and find a point that's on the graph, and then go over to the y-axis to estimate where that could be. So I'll try to do that again just to get it a little bit more on there. Okay, so it's hitting right about here, and that's hitting between 300 and 400. Now it's a little bit above the middle, okay, so the middle would be 350, a little bit above I would estimate 360. So this is again just an estimation, so we would say about 360 feet is a stopping distance at 60 miles per hour. Now we're given a function, f of x equals 0.0875 x squared minus 0.4x plus 66.6. This function models a car's required stopping distance, f of x in feet, on dry pavement, traveling at x miles per hour. So x is the mileage. Use this function to find the required stopping distance as 60 miles per hour and round to the nearest foot. So x is equal to 60, and so I'm trying to evaluate f of 60. So I want to change all the x's to 60 in this function and simplify. So I have 0.0875 times something squared, so that would be times 60 squared, minus 0.4 times something, so times 60, plus 66.6. So the next step would be to square our 60, so that would be 3,600. So we have 0.0875 times 3,600. And then negative 0.4 times 60 is equal to negative 24, and then I have plus 66.6. Next, I'm going to multiply 0.0875 times 3,600, that's 315. So I have 315 take away 24 plus 66.6. This is equal to 357.6, and if I round to the nearest whole number, that's closest to 358 feet. So the stopping distance at 60 miles per hour would be 358 feet according to this function rule. And if you compare that to the estimated answer we got in part A, we're pretty close with our estimation.